Hello, everyone. Today, we'll be starting the topics on soil physics. Okay, soil physics is one of the sub-areas in soil science. It was covered on the board exam, licensure exam for agriculture. Okay, please, I want you to please try to attend all the lectures in this series of lecture for soil physics because soil physics is one of very difficult sub-areas in soil science that has been included in the board exam, of course, for many years. There were many soil physics concepts that has been included. For example, during my time, there were many soil physics questions in the board exam. And during this lecture, uh, of course, maraming lalabas dito sa board exam, kaya huwag kayong mawawala. Susundan nyo talaga ang lecture ng soil physics. And of course, before anything else, I want you to please complete all those previous topics we have had discussed, like for example, the soil formation and development, soil formation, withering and rocks, and soil surveys and classifications. Please complete all those previous discussions before diving in, before jumping in into this soil physics lecture. So please sit back and relax and feel comfortable wherever you are right now because this topic is, I would say, difficult, but I tried to make it sure that it would appear simple during our discussions. Okay, so I think we have to start now. All right, so of course, this is a review for the soil physics, no? And okay, so first we are going into the different physical properties of the soil. So when we say soil physical properties, of the soil physics, we are referring to any physical properties that is observable and of course measurable, that can be seen and that can be observed. Okay, so one of the physical properties includes the depth. We're talking about here the depth of the soil profile. If you are if we are trying to see on this soil profile, this one, okay, so let me have the pointer first. Okay, in the side, so this soil profile, look at the depth. So so this different soil orders, different soils may have different soil depth depending on the withering process that that particular soils has been through. So the older the soils, the deeper is the soil depth. So soil depth is one of the physical properties. Okay, so the depth of individual horizon, we're talking about depth is the depth of individual horizon. So shall we say ang A horizon, so the depthness, there are some thick, there are some thick horizon and there are some thin horizon depending on the level of withering process. Then we, kasama sa depth, ito ang depth of the sulong. When we say sulong, we are referring to E and B horizon. So this is the A and this is the B, this is the B horizon. Okay, so B horizon. So sulong represents the E and B horizon. And also depth, included in the depth is the depth of the regolith. When we're trying to, we're talking about regolith, we're referring to the E, B, C horizon in the soil profile. So E, B, and C, this is the regolith. Excluded the bedrock. Okay? Then kasama sa concept ng depth of the soil is the effective depth. Mean to say, the maximum depth plant roots can readily penetrate without encountering a restrictive soil layer. So effective depth, a depth is the depth from up to where plants could penetrate without restrictive soil layer. So kung maabot siya ng roots na walang impedance, walang restriction, then that is refers to the effective depth of a soil profile. Okay, so effective depth may reach as far as C and even as far as bedrock for as long as the roots would able to penetrate on that layer. But kung hindi niya kaya mag-penetrate, so hindi na kasama ng effective depth yan. Okay, so other physical properties the soil has is the soil color. Of course, there are different colors of the soils. Some soils are red, darker, lighter, okay, depending on the particular factors that would affect the color of the soil. Okay, what is the importance or significance of the soil color? Soil color indicates soil productivity. So I think most of us, alam naman siguro natin na pag ang lupa ay maitim, darker in color, so we have an idea that particular soils are fertile and maybe productive, rich in minerals. For example, rich in nutrients. For example, humus are darker in color, and humus or organic soils are productive soils. Okay, so also colors serves an indicator for parent materials. So ang kulay ng mga lupa na resulting soils would tell us to what is the source of that soils before it has been through a complete of series of weathering. Kung galing siya sa mga black stones or black minerals, black rocks and minerals, and we would expect the resulting soils would be black. If it is or dark in color, if it is its parent materials is from lighter rocks and minerals, then we would also expect the lighter color of the resulting withered soils, withered rocks. And also the compositions of the rocks, the mineral composition of rocks, and of course, the compositions of the rocks, the chemical composition of rocks would affect eventually the color of the resulting soils. For example, if your rocks and minerals is rich in iron, then we would expect that the resulting soils would be red in color. Okay. Also, the soil color indicates a drainage condition. Kung gray ang color or abuhon, so ng lupa, then we would infer and would conclude maybe this particular soils has been submerged for many years in previous years. So ganun, no? Pag parang humol siya sa tubig sa mahabang panahon at ngayon ay nag-drain out na yung water, so mayroong mga evidences that live in the soils to indicate that the particular soils has been through a long period of submergence. Okay. Also, soil colors is an indicator of climatic condition. Okay. So, ang kulay ng mga lupa dito sa tropical countries, like Philippines is tropical countries, at sa kulay ng lupa doon sa, shall we say, humid countries at saka doon sa arid region, so we'd expect the different soil colors because that particular soils of different environments and of different climatic condition. Okay, so soil color. So how will we able to measure or how will we able to measure the soil color? The soil color could be measured based on the Munsell soil color chart. So the one on the pictures below, you can see this is the Munsell soil color chart. So ang purpose ng Munsell soil color chart is to measure quantitatively the color, the degree of color in the soil. So ang Munsell soil color chart is like a notebook and there are some leaves in there. So you can You can open the book, the notebook. Then there are some different ply and leaves on the notebook which has specific color. For example, we have to take samples or a pins or maybe pieces of soils on the ground, then try to compare that the color of that soil on the notebook, then you would able to identify the color of the particular soils. So, bakit importante malaman natin yung color ng lupa? Uh, it is important that we would able to tell the qualitative and the quantitative description of the soil color because it is difficult to describe colors without any measurement, so that researchers and readers, soil scientists, would able to understand what particular soils have been talked about when we talk about soil color. Okay, so this is the Munsell soil color chart. Okay, so what is the attributes? What are the attributes or aspects of soil color? How will the soil scientist will describe soil color? Okay, the attributes of soil color are the following. First, we have the hue. Hue, when we say hue, these are the dominant spectral colors. Okay, dominant spectral colors. When we look at the Munsell soil color chart, the hue value can be seen on the upper right corner of the Munsell soil color chart. In this particular example, you will observe on this ply, on this leaf of the Munsell soil color chart, that the hue value of this ply is the 10YR. So different ply, different leaves of the Munsell soil color charts must have a different hue value. For this particular leaves or leaf or ply, you can observe that this leaf has a 10YR hue value. And the most common soil hues are in the red to yellow, orange. Okay, if you are going to observe the color of the soils in the field, okay, the ranges of the color that we can see, the most common soil hue value are ranging from red to yellow. And a combination of red, a combination of yellow, that would somehow produce maybe light brown or any combination of red to yellow. But that is the most common soil hues are in the red to yellow range. Okay, so for example, the range of hue in red are 0 to 10R. Okay, the yellow red are 0 to 10YR, and the yellow hue are 0 to 10Y. But the combinations of red and yellow should be YR in hue. So this is it, no? So ang hue makita natin sa upper right corner of the ply or on the leaf of the Munsell soil color chart. So that is one of the attributes, hue. The next one is value. So we describe soils also in terms of value. Now the value, you can see the value is located left on the left side of the ply or left of the soil color chart. So ang value dito sa ito, no, sa left side. An example, we have the value. Itong row na ito, this row of colors, ang value niya is 8. Okay? Itong mga kulay naman dito, so sa susunod na row, ang value niya is 7. And so on, dito 6, dito 5, 4, 3, and 2. So take note that the value is on this side, on the left side. Okay? So what is value? Value is a degree of lightness or darkness of a color. So for example, if we have a dominant color of red, this is the hue, then kaano ba katingkad ang kulay red? Gaano ba katingkad yung kulay niya? So yun light red, dark red. So mayroon dong value ng red. Kung mayroong hue na red, mayroon ding value ng red in terms of lightness of red or darkness of a color red. Or ganun din, lightness of yellow and how dark is yellow. Okay? So yes, you have that one. So for example, mas light siya kung mas lighter siya kung taas yung value niya. Okay? Pagbaba yung value, so medyo darker siya ang kulay. For example, red, ang hue is 10, yeah. Then ang value is also 10. Ibig sabihin that is pure uh, ano, light red. Ganun, no? Okay. So far, that's it. No? Another attributes that we are going to describe soil color is the chroma. Chroma is a strength of a dominant spectral color. Chroma usually in apply or in a leaf of Monson soil color chart, makita mo dito sa bottom portion of the Monson soil color chart. And it is designated by a value which is the denominator. No, okay, we have 1, 2, 3, up to 8 in this particular example. Okay, this is when we say chroma, for example, in this particular example, it's increasing strength of color. So going to the right is increasing strength of color, and going to the left is increasing strength of grayness. Ito. So now, if you are to summarize now, so we will describe or there are three attributes of soil color. We have the hue, the value, and the chroma. Hue is in the upper right corner. The value is on the left side of the left, and the chroma is on the bottom side of the Munsell soil color chart, ply or left. All right. Reading a soil color. How will we able to read the soil color? So of course, kuha tayo ng sample ng lupa doon sa areas, doon sa field. Then try to take the samples and observe and compare the color of the actual soil sample on the Munsell soil color charts. Such as for example in this picture. So kumuha siya ng lupa at tiningnan niya kung alin doon sa lupa na yon nakapareho ng soil color do sa Munsell soil color chart. Then after doing so i-take niya kung ano ba ang hue value nito, ano ba ang value nito, at ano ba ang chroma measure nito. Okay? So tapos isusulat kung ano yung color ng soil. So very specific and very precise yung description ng color sa soil. Okay? The optimum conditions for reading soil color, we have to read soil colors in a natural light. Okay? Dapat hindi siya dim sa natural light condition. Should be in a clear sunny day because pag clear sunny day, so mabasa talaga natin yung kulay. We can compare it easily. So light at a right angles. So kung mayroong light, kailangan sa right angle, harapan sa right angle, no? And then the soil is moist. Ang lupa dapat hindi naman siya basa, hindi rin siya sobrang dry. Parang moist lang ng konti para makita talaga yung exact kulay ng actual soil. Dapat no sunglasses kasi nagre-reflect ang sunglasses ng light when we are going to read and compare actual soil color on the Munsell soil color chart. So ganun. So now, sa the Munsell soil color chart nga pala, is ito yung tools, ito yung charts na gagamitin para ma-measure natin yung mga attributes ng color sa ating mga lupa. Okay? So it's clear. Okay, yes. For example, yung lupa na yon, itong lupa na yon na tinatry natin. For example, it matches on this particular color. The actual soil matches on this particular color in the Munsell soil color chart. Then the value of that I don't know, the attributes of that color would be hue, which is 10YR, the value, which is 4, and the chroma, which is 2. So take note, no, parang ito yung mga intersection nila. Okay. Sorry. Okay. So intersection nila, so the value is 4 and the chroma is 3. Then therefore, the exact descriptions of a color of that particular source which has been sampled would be the 10YR 4/2. So the okay, the whole number is the hue, the numerator is the value, and the denominator is 2. So therefore, so we can describe the color now is that the color of my soil is 10YR 4/2. So with that, if we're going to publish this information on the literature or in the journal or on the internet, so the one who read the color, particularly a soil scientist or an agriculturist, they have now a common understanding and a common picture in mind that the soils we are talking about is of this particular color. So a soil moisture color chart now would ace an understanding as to what particular color the soil is being talked about. Okay, so the soil color name now is the dark grayish brown. Okay, the dark grayish brown. Kasi may mga pangalan yan dito. Tingnan mo dito. So dark grayish brown. Ito yung kulay niya, ang pangalan niya. So dark grayish brown. This is the exact color. Okay, so this is the Monson soil color chart, and it describes the attributes of the soil color and an exact and the right manner. Okay, so that is for the soil color. Another soil physical properties is soil texture. Okay, soil textures affect crop production. Soil textures affect the management and tilling in our field because there are soil textures difficult to plow. There are textures that are very easy to plow, and there are textures that are easy to conduct weeding, no? And there are textures difficult to conduct weeding. Ako ng lisod mangguna, sayon ra mangguna. Na for example, sayon ra daruhon ang mga sandy soils, ang mga loamy soils, lisod daruhon, lisod gunahan ang kaning mga clay soils na may ngana. Okay, how will we able to define soil texture? Soil textures is the proportion or relative proportion or a mixture or a ratio, a relative proportion of a three soil textural fractions of us or soil separates. When we say textural fractions or soil separates, the fractions or the separates we are talking about, we're talking about sand, silt, and clay in a given soil. If we have a bunch or a pins of soil, so that bunch or pins or cup of soils composed of different proportion, different fractions of sand, silt, and clay. Okay, that is the soil texture. So there are some sizes of soil separates recognized by USDA. Sinabi ko doon sa ating previous discussion that the Philippines has been following the United States Department of Agriculture in classifying soils. And although there are some ISS, the international system of soil classification, although there are other classification other than these two. In Canada, they have different classification. Other countries have different classification, but the most common is the USDA and the ISS. So what are the sizes of soil separates compared to the other? For example, what is the size of sand, silt, and clay? Okay, so in this example, sand, ang diameter ng sand in expressed in millimeter, we have in USDA, the upper limit diameter of the sand is 2 mm and up to 0.05 mm. But in the ISS, International System, the upper diameter limit ng sand is 2 mm, but the lower diameter limit of the International System for sand is 0.02 So, magkaiba, no? Sa SELT, under the USDA classification, ang diameter ng SELT is within this range. Okay? While the diameter limit of SELT in the international system is within this range. Okay? So let's look at the difference now. Okay? And in clay, so the diameter of clay in USD and ISS is less than or equal to 0.002 mm. They are the same. Okay. Try to familiarize it with that because usually sa board exam, ang lalabas na question is katulad nito. Ano ba ang upper diameter limit ng sand under the USDA classification? Or kaya, ano ang upper diameter limit ng sand in the ISS classification or the lower limit? So, ganun. So, please try to, nagbari lang naman sila dito sa dito sa 0.05 upper limit ng SELT at saka 0.02 upper limit ng SELT and also sa upper limit ng sand 0.05 sa USDA lower limit and lower limit ng ISS is 0.02 para sa ating sand. So take note for that. Okay? Although mixtures of the different mixture proportions of sand, silt, and clay produces another sub textural classification. So in fact, I think we have 12 in this particular example. Ang nakalagay dito is 1, 2, 3, 4, 5, 6, 7, 8. But there are 12, no? So because of different compositions of the sand, silt, and clay, different proportions, it enable us to produce another textural sizes, no? Okay, so for example, we have the very coarse sand, medium sand, fine sand, very fine sand, so on and so forth. Okay, now I want you to memorize, okay, I want you to memorize the gradation or the scale of different sizes of clay as to which is larger, which is smaller compared to the other, because the particle sizes has an implication in terms of fertilizer application, has an implication in terms of pesticide application. It has an implication in terms of water holding capacity. It has an implication in terms of drainage. And also it has an implication related to fertility, cation exchange capacity. So I want you to memorize, gusto na ko i-memorize ninyo ang sequence or ang gradation or ang scale ng sizes ng soil separate. Katulad nito. So, ang sand, mas malaki siya ang diameter niya kumpara sa very coarse sand. Ang very coarse sand, mas malaki ang diameter niya kumpara sa coarse sand. Ang medium sand, ang coarse sand, mas malaki siya kaysa medium sand. Ang medium sand, mas malaki siya sa fine sand. And ang very fine sand, mas malaki siya sa fine sand. Or pwede baliktad, mas maliit ang clay kumpara sa silt clay, mas maliit sa silt, mas maliit ang silt kumpara sa very fine sand, so on and so forth. Because ganito, pag maliit ang particle size, the finer the particle size, when it comes to a fertilizer application, marami tayong i-apply na abono doon sa mga finer particle. Ganun din, marami tayong i-apply na limestone doon sa mga finer particle. Ganun din, marami tayong i-apply na mga insecticides or pesticides doon sa mga finer particles ng mga lupa. Sa board exam, usually ang lalabas ay ganito. Which of the following textural size or which of the following soil textures requires a large amount of limestone, a large amount of fertilizer, large amount of pesticide? So, sa mga question na ganon, kung alin doon ang kailangan ng maraming abono, so piliin natin ang textures na pinakamaliit among the choices. Kung baliktad din naman ang question, alin dito ang alin sa mga texture na ito nangangailangan ng kaunting abono, kaunting limestone, kaunting pesticides. So again, among the choices of the texture, so you have to select yung mga malalaking particle sizes. So I guess, I hope you will know, you will understand as to what is the implication, as to what is the importance of soil texture now. So ganun din. So alin sa mga lupa na ito will hold more water. So ang answer din dyan, will hold more water, yung mga maliliit na mga textural diameter. Okay? Kung alin dito ang hindi mag-hold ng water, ito yung mga malaking diameter ng texture ng mga soils. So now, by now, I want you to please realize that there are some meaning on the sizes of soil textural diameter. So please be guided with that. Okay? Okay. So ang soil particles pala as ranges from equal to or more than 2 mm, no? So ito yung mga soil particle. So ang gravel is more than 2 mm, it is not considered. Gravel ranges from 2 mm to 3 inches. So hindi na ito kasali sa soil particles, no? Pebbles more than 3 inches to 10 inches, hindi na rin kasama ito ng soil particles. Ang cobble, which is more than 24, 10 to 24 inches, hindi na rin kasama ito ng boulders more than 24 inches. Ito ay mga rock fragments. They are not considered under the soil particles or the soil separates. So I want you to make it clear that take note, mga boulders, mga malalaking bato, more than 24 inches. Ang cobble is more than 10 to 24 inches. So please take note for this. During previous exams, ang lumabas doon is alin dito ang tinatawag na gravel, alin dito ang tinatawag na boulders. So please try to memorize with that and familiarize with that. Okay. So we have now generalized characteristics associated with the soil separates. Okay, sinabi ko kanina, sand, silt, and clay. Itong sand malaki kumpara sa silt. Itong silt malaki kumpara sa clay. So ganito, the water holding capacity of sand is low. So hindi siya nag-hold ng water. Kung mag-hold man siya, madali lang. Then ang water holding capacity ng silt is medium to high. Ang clay as high. No? Aeration, movement of air, good aeration in the sand, air could move freely under sand particles. Then moderate doon sa silt, ang poor ang aeration doon sa clay. So hindi maganda kung halos porous or clay lang lahat kasi mahirapan tayo sa aeration. Hindi rin maganda pag sandling lahat kasi hindi siya nag-hold ng water. So it should be a good mixture between sand, silt, and clay in order that you would say that the particular soils is of good texture. So dapat sa tamang proportion ng mga sand, silt, and clay para maganda yung aeration at maganda yung water holding capacity. Okay. So another characteristics of the related to soil texture is a drainage rate. So kung sand, so ang tubig, so mulapos-lapos lang ang tubig, no? Dili niya gunitan na rapid. So sa under the sandy soils, hindi siya lag, hindi siya water lag, hindi water lag, no? Ang drainage rate naman dito sa silt is low to medium. Dito naman sa clay, ang drainage rate is very slow. Ibig sabihin, pag umulan, clay yung lupa, so parang magkaano tayo, no? Maputik, no? Ang tubig is just stay on the ground, kaya mahirap siya ma-drain. So compactability, yung parang mugahi siya, no? Compactability. So madali mag-compact itong clay, no? Mas compact itong clay, pero hindi gaanong compacted itong sand. Mahirap i-compact yung sand. Kung mayroon kang sand, try it to compact, di ba? Mahirap, hindi siya mag-aggregate, hindi siya mag-kumpol. Okay, ang silt naman is medium compactability. Okay, so ibig sabihin dito, mas taas o bulk density ang clay kumpara sa sand. Okay, so taas o mataas ang compactability ng clay kumpara doon sa sand. Okay? So nutrient water holding capacity, so ibig sabihin, sand will hold more nutrients in the soil surface. Then, sand will hold small amounts of nutrients and clay hold high amounts of nutrients. So ngayon, mas fertile ngayon yung sand, yung clay, mas fertile yung clay kumpara ng sand. Okay? So buffering capacity, I know say the buffering capacity is defined as the capacity of the soils to resist on the changes, to resist drastic change. Ang clay has a high buffering capacity and ang sand is a low buffering capacity. Buffering capacity is also related to the applications of fertilizers, applications of lime. Now, kung mataas yung buffering capacity ng lupa, marami tayong i-add doon na fertilizer. Marami tayong i-add na doon na mga limestone. Marami tayong i-add doon na mga pesticides. Okay? Because itong mga textural classes is related to the surface area. Ganito. Pag maliliit yung mga texture, the finer the texture, the higher is the surface area. The higher is the surface area, the higher is the buffering capacity, the higher is the nutrient holding capacity, and the higher is the amount of fertilizers, amount of lime, and amount of pesticide to be applied in that particular soils compared to the coarser or the bigger diameter sizes textures. Okay. So now, the total surface area of the sand is low, okay, because malalaki ang particle nito. Again, the total surface area of sand is low because malalaki ang particles nito. The bigger the particles, the smaller is the total surface area. Dito naman sa clay, mataas ang surface area nito kasi maliliit yung textural diameter size niya. So pag maliliit yung diameter ng texture, the higher is the surface area. Ano yan? So please try to understand this concept clearly and what is the implications of different textural classes in terms of water holding capacity, aeration, drainage, compactability, nutrient holding capacity, buffering capacity, and total surface area. And also, this characteristic has an implication doon sa chemical reaction and the biological reaction later on. Okay? So please try to understand that. And please try to know as to what is the application if we have the smaller particles or the bigger particles in terms of these characteristics. Okay, so let's try to move on now. Okay, so if we have different textures, textures will be determined using the methods such as field method, roll method, and mechanical analysis method. But I guess we have to continue the discussion on the next session because we have so far have discussed a very long discussion. So we have to stop up to that and have to continue next time. So, okay. All right. So if you're feeling bored, feeling tired right now, also let's diffuse yourself. So let us have a relax and let us continue on the next discussion.